Good afternoon. It's great to be with you guys today. I just want to thank the organizers of the conference. They've been so gracious. It's my first time here in Korea. Really excited to be here, and really excited to be building with you guys. And I want to just say that I really enjoyed the theme of the conference as well, proof of developer, because we're in this kind of weird state right now where the markets are down, but there hasn't been more activity now than, there's more activity going on now than any other time, and more developer work. And I think that's where the real magic is happening. So I'd say keep it up, and let's try to learn from this event that we're having today, and gain some confidence, learn from each other, and have a good time here. So thanks a lot. So you've been coding for too long when you find yourself Googling for something and because you forgot how to do it, and you actually run into yourself asking the same question 5 years ago on Stack Overflow, right? I had an experience kind of like this the other day when I was looking for materials around privacy and surveillance and some of the things that we're concerned about at Mainframe. And I found myself asking this question. So I want to cast your minds back to this interesting time in our history that I think was an inflection point that's brought us to where we are today. I asked on the Stack Exchange site called Information Security, will we ever get to a point where the core protocols of the internet are robust and secure enough that surveillance and centralized control of the internet become effectively infeasible? So this was happening around 2014, 2013 or so, and you'll recall that at this time, we all became aware of some really kind of disturbing events in our world. And it happened because a brave individual was aware of authorities, overreaching and invading our privacy in different ways that we were not even aware of. It took us all by surprise. I mean, even the biggest enterprises like Google became aware that their undersea cables, for example, connecting their data centers together, were being tapped into by certain government authorities. And these revelations from Edward Snowden actually set back, I would say, the work of the intelligence community probably by several decades. Because it really alerted all of us engineers to some challenges and weaknesses in the protocols that run the internet today. And so I'm here to start out my discussion by talking about and reviewing some of those challenges. We're all trying to get to this state where we have safer applications, where we have applications that effectively eliminate the threat of these kinds of censorship and surveillance that occur by these authorities that we're discussing and in various contexts. But it's a long road. We need several components. There are several weaknesses in the current protocols that run the internet. So one of the first weaknesses we have is around addressing. So the IP protocols that run the internet today have this feature, bug, whatever you want to call it, that essentially, if you know somebody's IP address, you know where they are on the globe. And you don't just know what country they're in or what state they're in. You know, what neighborhood they're in, right? So addresses are geolocatable. Not only that, but if I know what address you have, I can also complain about the content that you're posting in some way. And if you've, if you're posting someone that someone doesn't like or that goes against certain values or certain ideas. If someone who is powerful enough doesn't want you to share that information, they can use various means to block you from the internet and to take you offline. So as we move to what we're calling Web 3, we need something that removes this awareness of geolocation. And one of the technologies that we're using to accomplish that is a peer-to-peer overlay, where the addresses of each node in this peer-to-peer network don't really tell you anything about where these individuals are located. where these computers are located. So this overlay doesn't really match the physical topology of the internet. You might be wondering as I go through this, what happened to Web 1, right? Why are we moving from Web 2 to Web 3? Well, for those who aren't familiar with the terminology, really Web 1 was that time when you had like Yahoo and some static directories, and people were publishing content on the internet that was just being consumed by end users, but the end users were not really producing much content of their own. So Web 2 brought us social media where people are interacting with each other, where applications are becoming more dynamic, and but we're still dealing with the regular protocols of the internet. And Web 3 is this new phase that we're discussing now. Another feature that is a weakness in today's internet protocols is domain name services. So domain name services are hierarchical in nature. There is a central authority that's in charge of deciding who gets what domain, and if someone decides that you don't deserve this domain, or that this domain needs to be taken away from you, then there are various means that they can use to do that. So we need to move to another paradigm. And this paradigm is that these domain name services would be managed on a blockchain or some other distributed, decentralized consensus mechanism. So there's various solutions for this out right now. One of them is Ethereum name service. There's others such as Namecoin and a few others that have come out as well. And this is really important because we don't think in numbers, right? We think in memorable human names that we need to attach to things. So we need some way of doing that, some way of addressing. The classic solution, the classic first problem that was solved by all of these blockchain technologies was payments. So we now have the ability to transfer value across jurisdictional boundaries in near real time. And in many ways, this has revolutionized the payment industry and is disrupting them in various ways. So we move from the card networks and other things to cryptocurrencies. But we need additional things as well. So any application that is functioning on the internet needs to be able to ensure the privacy of its users. And sometimes we think that it's sufficient just to have encryption in order to do this. But actually, merely being able to keep the content of your communications private is not always enough. For example, if I know that two parties are communicating with each other, sometimes that information in and of itself is sufficient for them to be endangered or for their work to somehow be threatened. Another challenge that you have is that even if knowing who's communicating may not matter too much, it might be possible for someone to jam or block the communications of various individuals. So these two properties we would call censorship and surveillance. Censorship, the ability to block, and surveillance, the ability to see that communication is happening. And so we need a communications protocol for the internet that achieves both of these, that resists both of these threats. And I have over here on the right-hand side an example of a communications protocol that we've been developing that does this. So this uses a technique that we call dark routing. And in this example, you see a node AC that wants to communicate with node BC. And so it prepares a data packet that's encrypted for node BC. But it only supplies a partial address on that data packet. And so that data packet is routed efficiently towards nodes that match that address. But once the data packet reaches the nodes that match the partial address, instead of reaching only one node, it gets broadcast to all of the nodes that match the address. So you see this whole cluster of nodes beginning with B is all targeted by that packet. But only the final recipient, the intended recipient BC, actually receives the packet. And what's really interesting about this strategy for communications is that within this zone of broadcast, it's very difficult to observe the network and say where the packet is originating from and where it's destined to. So within that zone, you have effective anti-surveillance and anti-censorship. And what we're providing in addition to this protocol is network inference utilities that will help the user to know sort of what the network conditions are and what is a safe amount of addressing to use to achieve the level of censorship resistance and surveillance resistance that they require. And that may also depend a little bit on the type of application that they're actually running. So we would try to provide tools to the user to help them figure that out. Another important feature that every application needs is the ability to store data. So file storage right now, even in the distributed app, decentralized world, is largely being provided by existing infrastructure that's using Web 2 protocols. And this is, I would say, right now, kind of the Achilles heel or the great weakness in a lot of the dApps that are out there, is they might be using a blockchain for certain key events, but they're largely relying on existing infrastructure and therefore have the same weaknesses that the current protocols of the internet have. And what we're all trying to get to is this holy grail where all of the various services that an app requires to function are provided in a fully decentralized way. And at Mainframe, we're working really hard on this problem. So in this file storage layer that we're helping to build, they're basically files and any other data that you want to store in this layer get chunked into small chunks. And those get distributed. And nodes have an incentive to replicate these fragments of files, because if these fragments of files are in high demand, a node, every time a fragment is requested, a node gets a small payment for providing that file. So let's say that Taylor Swift has released her latest album, and you say, I think that content is going to be pretty in high demand, so I'm going to replicate that content. So what's interesting about this network is that it naturally scales with the popularity of the content. And then for data that's more kind of only interesting to the actual user of an application, like personal data that you just want to store for your messages or whatever your personal data is, that's something that the user would also pay nodes to store. And they would pay in accordance with how much redundancy they require. So there are various incentivization strategies for this file storage layer. We also need the ability to randomly access data very quickly. And this is what the data services layer is for. So rather than storing large static blobs, data services provides in a peer-to-peer fashion a replicated clustered database. And we see here on the right an example of like a way of implementing a user's mailbox in a distributed fashion. But as you can see, this virtual database is really provided over a peer-to-peer network underneath. Another important feature of decentralized apps is the ability to do computation while the devices of the user are all offline, or perhaps if the user's devices don't have the computational capacity to really calculate all the data that's required. So we need a computing services layer that can perform these tasks on the user's data while their devices are offline, and then maybe send a push notification or cause other events to occur in the absence of the clients from being connected. One really important feature that is inherent in all of these layers that I've described, or that needs to be, is incentivization. So at Mainframe, we've been at work for many years on the problem of messaging in various forms. And one of the things we discovered as we were creating a federated sort of decentralized message system that was an improvement on the existing SMTP protocol was that all of our users, even though they had the ability to install their own nodes, really had no strong incentive to do so. So it ended up just being Mainframe running all of those nodes. And really what we ended up with was this totally centralized, siloed situation where, like we already have today, where we have Facebook, Google, various other players who are really running and owning the messaging systems of today. So by show of hands, I'm just curious, how many people here actually use a Gmail account? for a lot of their communications, right? So we have this situation where we have major centralization going on in our messaging, right? And that's something that we want to move away from. But this incentivization is challenging. So one of the things that I want to discuss today is some of the necessary features of any incentivization strategy for it to succeed. And this comes from Mike Golden's work on his Crypto Systems Manifesto. So a token has to be a necessary element of a self-sustaining system, which is a public utility. And we'll get into what those things mean. First, it's necessary if getting rid of this token would somehow reduce the functionality or mess things up. And it's kind of hard sometimes to understand what this first component is. Really, it's kind of what we have today. It's sort of like what problems occur in the absence of a properly incentivized system. But this one, I think, this next one is really important. And it says that whatever incentivization system you create really needs to be able to continue functioning even if the implementers of this system totally walked away and just didn't work on it after that. So that's really our goal, I would say, as we'll know we'll have achieved our goal if the systems, the apps, the other things that we create, even if we decide to fold and walk away, there's still an active, lively user base that continues to perpetuate these tools long after we are gone. And then a system is a public utility if anybody can get into it, right? So Bitcoin, anybody can run a node. That's an example of a public utility, whereas some of these maybe more enterprise blockchains that we've seen that are private might not qualify as a public utility. So these are some of the aspects of a token economy that Mike has identified. And incentivization is actually very difficult because when we create incentivization systems, we're creating rewards for certain types of behavior, right? And so I have here some work from Trent McConaughey where he's highlighting some of these challenges. He says, you can get people to do stuff by rewarding them with tokens. So blockchains become incentive machines. I see this as a superpower. The block rewards function defines what you want network participants to do, and then the question is, what do you want people in your network to do? It has a crucial corollary. How well can you communicate that intent to the machines? This is a devilish detail. Do we really know how to design incentives? What's interesting about this is that if we incentivize the wrong behavior, we can produce disastrous results. And what makes things even worse is that we may not see the problems of those results until the system is entrenched, until it's widely distributed, until everyone's using it. And then only under certain economic conditions may we observe these problems. So we have to think really hard and really carefully about the incentive systems that we build. This is also echoed by Elad Verbin in his excellent article entitled Behavioral Crypto Economics. So under blockchain systems where code is law etched in stone and deployed to a wide community of pseudonymous stakeholders, good incentive systems are all the harder to get right. We've got to be careful. And he says we have to hire people with several disciplines. Maybe those people on the humanities side of the equation as well, who can talk to us about sociology, about economics, and other kinds of things to understand how people behave, because people don't always behave rationally. And so, when we involve human actors in our incentivization systems, it's especially challenging. So this is just kind of a lead into some of the work we're doing at Mainframe that I'm really excited about. What we're doing at Mainframe is we're really trying to unify a lot of these different service layers that I outlined under a single, easy-to-use SDK. And with these service layers, we've taken the approach that we can't always pick the winning horse, right? So, one of the things that I also, it looks like they're using my old slides. I gave them some newer ones, but they don't have them up. But I had an identity layer there as well. Anyway, we're using these various layers, and we're trying to make them modular so that various service layers and projects that are underneath these can be used to provide these various incentivized services. So our idea here is that we want to make it possible to for users and developers to plug in the things that they prefer to use for these. And we're going to pick what we see as some of the projects that are furthest ahead and approach those first and implement those first, integrate with them. But we will also be looking at additional projects that will help us to achieve this interoperability. Because this is really the big challenge that we see right now in the industry, is that each project seems to be solving one or two pieces of that pie, and everyone's left kind of having to build 3 or 4 other startups before they even get to the actual startup that they want to build, right? So this is where we see a lot of our value add, right? All right, let's see. Another thing that I should point out is that as we build up this platform, we will actually be using the platform itself to implement some of the platform. So one of the first tools that we are looking at building is a marketplace, for example, where we can allow users to deploy their dApps and also curate the dApps that are available through a token curated registry. We're also providing a flagship product around messaging. And we want these reference dApps that we build to really help developers to know how to build on our platform, to help find bugs in the platform, and to really kind of eat our own dog food, if you will. Or as I like to say, drink our own champagne. And on top of all this, you are going to be building your dApp. So, you know, we're trying to take a page. I look at one of my favorite companies, which is Stripe, where the way they won this strategy was by just making things so darn easy that the developers all prefer to use that solution. And when you're talking to your manager about what solution you want to use, and the developer says, look, we could use product A and it would take 2 weeks, or we could use product B and it would take 2 days, almost in all cases, the manager is going to go with product B. And that's what Stripe succeeded in doing, and that's what we would like to as well. So as you can see, underneath each of these service layers, we have various projects that are making progress in these areas. So the first blockchain that we're focused on is Ethereum. And we use this blockchain for settlement between our various nodes for their incentivization. But one of the clever aspects of our incentivization algorithm is that it relies on off-chain cryptographic proofs for most of its work. So it's possible for nodes to accumulate services, to accumulate records of services that have been consumed and services that have been provided, and to charge each other for these services without actually having to go on the chain. And then occasionally when the nodes decide that they've accumulated enough credit that they need to now settle their transactions, then they can do so on chain. So the nice thing about this strategy is that it really doesn't, it means that even the scaling level that we have today on Ethereum and other blockchains is sufficient for our needs for the incentivization layer. And you can see various other layers here. So where we've started our work is under the communications, the payments, and the file storage layer. And we've been collaborating closely with the Ethereum core team on a project called Swarm that's providing that incentivized storage layer, and also a protocol called Postal Service over Swarm that provides the communications layer. Another important thing is that each of these projects, and in several cases, has a token economy of its own. So the question is, how do we make it easy on the user and the developer so that they don't have to worry about holding wallets with all of these various tokens in order just to use our services? So we're employing various liquidity pools and other means of swapping tokens automatically underneath the hood in a way that is convenient and easy for them. And these atomic swaps then basically make it so the developer doesn't have to worry about those things. And we even envision providing the user, the developer, with their own dApp coins if they want to. And these dApp coins could then also use our token, the mainframe token MFT, which is a common medium of exchange. And it could all be swapped under the hood. As I mentioned, we have several reference dApps that we're going to be building to kind of showcase and exercise the platform. And finally, we really need good documentation. We know that the project is only going to be great if you can actually figure out how to use it. So we intend to support several platforms with a product that we're calling, at least the code word for it is our launcher, although we're still working on how best to market that. But I'll be showing a screenshot of the launcher, actually, if they have the latest slides. And this will be supported on several platforms. One of the first languages that we're going to be providing our SDK in is JavaScript, but we're also looking at several polyglot tools to allow it to be provided in your language of choice. And as I said, we have these several reference dApps. And we're very eager to communicate with the rest of the community and to find out the kinds of dApps that you're interested in building. And our token pool actually has a significant amount of tokens reserved for key infrastructure and other projects in the space. So we're happy to help dApp developers build things, and we have resources dedicated to that. So please get in touch with us for that. In summary, Mainframe is going to be the easiest platform to develop your dApp on. We want to make it fun. We want to make it your first choice. We have several communications channels that I'd invite you to reach out to us on. So we're also working with local communities all around the globe. You may have already seen some of the work we've done with our airdrops. We've got just, I'm really excited to be working with this marketing and business development team because it's the first time as someone on the technical side of the company that I just really haven't had to worry. They've done some great work trying to build goodwill in the community and build up various communities throughout the world. And we'd invite you to join us in these local meetups as they crop up as well. So on our website, we recently released a roadmap that outlines the progress we've already made on our platform. And so I'd invite you to check out our website, mainframe.com, and take a look at what we're doing there. And there's also some links there that can show you how to get involved and how to start working with us. And kind of to give an overview, essentially, we're working with some private partners right now, but we're looking at being able to have some public-facing APIs available and ready to use around the end of the year. And we're really anxious to help you to build your dApps on our platform. So please reach out to us and get in touch. We also have a growing team. Once again, old slides. This team page is about twice as big now. And more diverse as well. So anyway, please, we're still looking for great engineers and would love to talk to you. Great people of all stripes, so please get in touch. And with that, I want to thank you for your time today and open this up for any questions.
Well, thank you very much. So during your presentation, the audience has left several questions about the Onyx and others. So I would like to ask some of questions to you. The first question is, I have a question about Onyx now being under development by Mainframe. This is known as an application which provides experiences as Slack through blockchain networks. So I wonder if it can record all conversations of users and contents, including images or text files, which is transactioned.
Yeah, so Onyx, the final feature set of Onyx is still in a state of flux. So I would hesitate to say that it's going to be just a Slack clone. Although some of the functionality provided in Slack is something that we definitely want to do in Onyx. And this is kind of where our other service layers really come into play here, because I talked about the storage layer, and so you know, as you can imagine with Slack, it wouldn't be very useful if you opened up your Slack client and all of your messages were gone every time you did that. So when you come back to your app, you like to see that your data is still there the way you remember it last time. And that's where the file storage layer that Mainframe is working on will come in handy. And we're looking forward to demonstrating persistent messaging at DevCon or their roundabout DevCon with some of the work that we've been doing there. So yes, you will definitely be able to access all of the file attachments and other messages in an auditable way on Mainframe and through the Onyx dApp.
Okay, that's great to hear that. Okay, and I would like to ask another question. The second question is, there is so many services for vertical infrastructure to create decentralized storage or computing power, but I think Mainframe want to cover it all. So isn't it so big to solve the problem for just one organization? I'm fascinated Mainframe's idea, but I'm worried about how and when it can be made.
Thanks. Yeah, so like I was saying, our approach is really to leverage the projects that we think are furthest along, to contribute to them where it makes sense to do so, and to kind of help them along. But we don't, you know, we see ourselves as standing on the shoulders of giants and not trying to build it all ourselves. So a lot of our value add is in the unified API, the ease of use, and we're leveraging several projects that are already underway to provide those several service layers. So in that sense, it's not quite as much, I mean, it's still a lot of effort, but it's not like we're actually trying to build all of these projects from scratch on our own.
Okay. I would like to ask one last question.
Sure.
The next question is, I'm curious how you are going to build Mainframe's own token pool and distribute them to the users. Have you already designed the company's own reward engine?
So this sounds like this question is getting into a couple of different things. So in terms of just how we're distributing tokens, we're just using some standard smart contracts to distribute tokens to investors who are already on a vesting schedule, or to various contributors. But there's also a question in here that sounds like it's hinting at incentivization. And as far as how that functions, one of the key incentivization mechanisms that we've identified as something we would like to use and contribute to is called swap, swear, and swindle. That was first introduced by members of the Swarm team. And this is a generic incentivization mechanism that can be applied to several different types of services. And so the way this incentivization strategy works is essentially that users provide proof that they're performing the services that they claim to be, and a jury of peers can be assembled to also punish some slash some staked tokens if the user is shown, the node is shown to be violating its agreement. And so we're working on this. It's not fully implemented yet, but it's underway, and rapid progress is being made. I would say that incentivization is one of the later things that we're going to be fully releasing. Our approach is to release functional service layers, even if they're partially supported by ourselves and other key players in the space, and then eventually incentivize all these services so that they're fully self-sustaining.
Oh, okay, thank you, and great to hear that as well. And so thank you very much for a great answer and sharing your knowledge, so you can return to your seats.
Thank you.